Hello students, in this video we'll see how to solve problem 4.8.4. Problem 4.8.4 asks us to find the eigenvalues and eigenvectors of the matrix 3, 0, 8, negative 1. To find the eigenvalues, we compute the characteristic equation. We call this matrix over here A. Then we have the determinant of A minus lambda times the identity equals 0. So that will tell us that the determinant of 3 minus lambda, 0, 8, negative 1 minus lambda is equal to 0. So what I'll do is I will just subtract off from the main diagonal lambdas and leave everything else the same for the matrix in the characteristic equation. Now to compute the determinant, we multiply the diagonal entries, get a plus sign, and multiply the off diagonal entries, and they get a negative sign. So the determinant will be 3 minus lambda, negative 1 minus lambda, minus 0 times 8 equals 0. And we can simplify this as lambda minus 3 times lambda plus 1 equals 0 by pulling out a negative from both terms, which tells me that the eigenvalues are lambda equals 3 or lambda equals negative 1. Now to find the eigenvectors, we want a vector v1, v2 such that A minus lambda times the identity v, this is the vector v, is equal to 0 while v itself is not 0. So when lambda is equal to 3, what this amounts to, as we look at our matrix, if I plug in if I subtract off 3 from the main diagonal, I'll have a 0, an 8, and a negative 1 minus 3 is negative 4 applied to v1, v2. I want this to be equal to 0, 0. The first entry doesn't tell me anything. The second entry tells me that 8v1 minus 4v2 equals 0. So that means that we have a whole bunch of possibilities for solutions over here. We could choose v1 to be 1 and v2 to be 2, and that would be one possibility. Now with eigenvectors, there are infinitely many correct answers. They're all scalar multiples of each other, so any one of them will suffice. When lambda is equal to negative 1, I'm going to subtract off negative 1 from the main diagonal. So I'll have a 4, a 0, an 8, and a 0 applied to v1, v2 being equal to 0, 0. And now the first entry tells me that 4v1 equals 0. And the second entry tells me that 8v1 equals 0. Together they tell me that v1 has to be 0, but v2 can be anything it likes. So one possible answer would be 0, which is the force value of v1, and 1 for v2 would be an appropriate choice of eigenvector. So we have our eigenvalues of 3 and negative 1. The eigenvector corresponding to 3 is 1, 2. The eigenvector corresponding to negative 1 is 0, 1, and that's the solution to the problem. Thank you very much.